with this challenge of you didn't know what A and B were and you figured you were going to go and try and find them. Okay, Eric started that way. And did you quickly change your mind and go with the other option? So I'm going to assume everybody else did this too. And we said A is going to be 2 and B is going to be -5, and let's go from there. All right, so A, determine whether or not F is differentiable at x equals 1. Here's what I'm looking for. Jackie, let's make sure we get all of this copied down. If F is going to be differentiable, right, that's the question. Differentiable at x equals 1, then the first thing you have to show me, show me, what's the first thing?
The derivative.
Not the derivative, even before you go that route. Before you check differentiability, you check something else. Delia, what's the thing?
Continuity.
You want to check continuity at x equals 1. So what I need to see on your paper is that you found f of 1. You found the limit as x approaches 1. For those of you that did not do this for some reason, you are getting this copied down into your notes. So if I turn around, 16 people are working here. F of 1 is going to be 2 times 1 squared plus 5 times 1 minus 4, which I think is 3. The limit as x approaches 1 from the left. Limit as x approaches 1 from the left. Wait, did I do that wrong?
Yeah,
It's plus 4.
It's plus 4. So minus 5 there, plus 4 there, and we get 1. Thank God, thank God. Limit as x approaches 1 from the left. That means the limit as x approaches 1 from the left of 1 over x, 1. Limit as x approaches 1 from the right. The function that I'm using here is 2x squared minus 5x plus 4. Hey, good news, 1. Your conclusion?
Continuous.
F, not differentiable,
Continuous.
is continuous
X equals 1.
at x equals 1. Now you go for the derivative. You have to go for the derivative. So we look at the limit as x approaches 1 from the left of f prime. We look for the limit as x approaches 1 from the right of f prime. Now on the left of 1, what's f prime? If f is 1 over x, I have to find the derivative of this piece. So when I ask the question, what's the derivative of 1 over x, you either have it memorized or you said, oh, make that x to the -1. And then the power rule says -1x to the -2, so we get -1 over x squared. What's the limit then as x approaches 1 from the left of -1 over x squared? Well, that's -1. The limit as x approaches 1 from the right. If I'm approaching 1 from the right, what's the derivative here? Oh my gosh, there's one person out of 16 that seems to be with me on this. Limit as x approaches 1 from the right. This guy's derivative should be 4x minus 5. Limit as x approaches 1 from the right there. -1. The function is continuous at x equals 1. The limit from the left on the derivative is -1. The limit on the right of the derivative is -1. Your conclusion at this point? The function, f, is differentiable at x equals 1. If for some reason you don't have this exactly in your homework, get that copied down now. I am not picking up assignment number 23 for a grade. The one tomorrow has a bunch of these problems on differentiability. You want one more model in your notes? This is what it looks like. Okay. Now, if all goes well, for those of you that did the homework last night, what you would have gotten is that at x equals 4, the function is continuous, but it's not differentiable. I went through, and when I did this, I did the work a little bit differently. I went old school. I said, let me find the limit as x approaches 4 from the left using our definition, f of x minus f of 4 over x minus 4. And I plugged everything in. And I simplified. And I factored. And stuff canceled, and I got 11. And if you just find the derivative in the shortcut way, you get 11. I found the limit as x approaches 4 from the right, f of x minus f of 4 over x minus 4. Different function. Here I'm going to multiply by that fancy one, by the conjugate. I'm going to get 3 over 2. Derivative on the left is 11. Derivative on the right is 3 over 2. The conclusion? The function is not differentiable. These two guys aren't equal to each other, so it's not differentiable. Okay? The next one, I asked for what? F prime of negative 1. F prime of negative 1, you could do limit as x approaches negative 1, f of x minus f of negative 1 over x minus negative 1. And you're going to get negative 1. Guess what? If you use your derivative shortcut, you're still going to get negative 1. You just get there faster. This is why you want to do this. Your conclusion, since f prime of negative 1 is less than 0, f is decreasing at x equals negative 1. Last one we're going to look at is part E. This one asks to find this equation of the tangent line. To find an equation of a tangent line, I need slope at 9, f prime of 9, limit x approaches 9, f of x minus f of 9 over x minus 9. You get 1. The 1 is the slope. The equation of your tangent line is going to be 1 times x minus 9 plus 22. 22 must be the y value when you plug in 9. To approximate the value of the function at 9.2, you plug 9.2 in, and you could stop here, or if you simplify, you get 22.2. How do we do with part E? I care greatly about part E because this was a butt whooping on the unit test, and we took the time to go over this Monday so that it goes better. Okay, so you guys can put that away. Couple of quick things. Because it's a Wednesday, I am not available for lunch support at all. I need to head out of here right at 10:30. So if you're walking around on campus at 10:30 and you see me running out to my car, you're like, hey, Mr. DeRozier, just get out of my way. I might knock you down. Okay, tonight's homework, and for those of you that this matters to, is round 1 and round 2 of assignment number 24. It is getting picked up for a grade tomorrow. I guarantee that. Okay. It's assignment number 24, rounds 1 and 2. Kaylin, you were on the board just because I needed to take a picture of your test. I already did that. Jackie, it was the same thing. Good. Assignment number 24, I don't know what the page number is. Rounds, what page?
48.
48.
48. Round 1 and round 2 only. There's a section at the bottom called round 3. Not interested in round 3 yet. We're not ready for round 3. Round 1 and round 2 due tomorrow. Oh, Jose and Ivan. Okay. Check, check, check. All right. We're going to transition into a little bit of an exploration. I need you guys to turn to page 12. Kevin, how do you feel about being the driver today? No, you don't want to be the driver? Too much responsibility? Okay, Abraham, can I get your drive? Okay, you're going to come back here. Everybody's going to need a pencil, and you're going to want probably some colored pens or pencils or a marker.
How many?
Just a couple. A couple you guys could share as a group, because that's what this group does. Okie dokie. All right, so at the top of page 12, rather than have anybody read this out, I just want to do a quick summary. At the top of page 12, there are some formulas that should be very, very familiar. F prime of A equals the limit as x approaches A, f of x minus f of A over x minus A. You guys know what this is? What is this? This is slope of tangent line. This is derivative, right? This is tan. They're all saying the same thing. Okay, but when you use this one, this is going to tell you the slope of the tangent line at one point, right? You're going to get an answer that's like 5, negative 6, 17. You could also go with this version. This is another legal way to find the derivative. However, if you use this limit as h approaches 0, f of x plus h minus f of x all over h, this is going to give you the derivative everywhere. It's going to give you the derivative as a function, as some algebraic thing you can work with. This whole unit is going to be looking at the derivative as a function. as its own graph, as its own entity. And so what I want to do is we're going to do a little bit of an exploration here. Abraham, you're only going to hit the buttons that I ask you to hit. You guys are going to want to get this in your notes. Life is good. All right, so we've got Geometry Sketchpad. And what we're looking at is a graph of some function f of x. Oohing and ahhing is going to start happening. Abraham, click the Show XP tan seg. Okay? At this point P, fancy word for point P? What's the fancy word for point P? It is a point on the graph that I'm really interested in. This is the point of tangency. This is the place, Jackie, are we okay?
Yeah.
Okay. So point P is your point of tangency. Abraham, I want you to make this a little bit longer. See if you can. Click on this black dot over here, and can you drag it to the right? And that's just going to make your tangent line a little bit longer so you can see it better. All right, that's good enough. Don't go crazy. Okay, slide X. Feel free to ooh and ah whenever the spirit moves you. Ooh. Ah. Okay, so all we're seeing right now is we're seeing our point of tangency as it moves to different places on the graph and the tangent line at this point. Now what's happening over here? The blue and the green, the blue is telling you the y value at each of these points. So as point P moves, the x value changes, so does the y value. The green is telling you what's the slope of the tangent line at this particular point. We're okay? Okay, good. All right, I want to introduce a new idea. Abraham, click on the button that says Show XF prime. And so now we've got this new green dot. And what I want you to do is take a minute. Let your smarticle particles do their thing here. What's going on with the green dot?
Isn't it showing the derivative?
Why does it move in the way that it does? Don't talk to me. Talk to the folks around you. Why is it showing up in the places that it does?
It's showing at the maximum and minimum, no? The what? It's showing at the maximum and minimum. Yeah, minimum, maximum, minimum. Oh, I see that.
Okay. Can you commit to when you find it, take a picture of the cover, etc.?
Yes.
Okay. I want to get some hands on this. What's going on with the green dot? What are the theories that are out there? Jackie, what you got?
That it's like touching like P when it's like at maximums and minimum.
Okay, what I hear you saying is it's touching P when we're at maximums and minimums. What other theories are out there? Beto.
It's tracing the derivative.
It's tracing the derivative, maybe. Right now, this is just a point that seems to be shadowing point P. Let me show you something else that kind of ties into what Beto just said with the whole tracing. Show F prime, Abraham. This introduces a new graph. I want you to take a minute, get the green graph copied into your notes as carefully as you can. You might want to go with the pencil first and then trace it with the marker. Get that graph copied into your notes. Doesn't have to be green. Careful, I heard that. It's the advantage of having big ears and standing 8 inches away from you. As mathematicians, what I'm hoping is happening is that you're looking at that blue graph, you're looking at the green graph, and your brain is starting to make some connections here. There are some things that are happening on the blue graph that's causing particular behavior on the green graph. Any brave souls have some ideas out there? Carlos, what you got?
When the graph is going.
Okay, I want you to be specific. I heard you start with when the graph. Which one? The blue graph or the green graph? The original function or f prime?
When the original function
When the original function is doing what?
is increasing.
When the original function is increasing. So for example, There's a place when the original graph is increasing. That original graph is increasing. What do you know about the derivative graph? It's also increasing? Is that true? What Carlos just said is when the blue graph is increasing, the derivative graph is also increasing. True or false?
False.
If there's any place where the green graph isn't also increasing, then your thought doesn't work. I see the blue graph increasing this whole way. The green graph is increasing, but then we start to decrease and then we increase again. So good idea, didn't work. Is there a connection between the blue graph and the green graph? What do you say?
The slope.
What about the slope?
So like when it comes first, it's going like steeper. Then as it continues going down.
Yeah.
So then it's going steeper then again.
Okay, the blue graph we are decreasing, and we're decreasing in a really like steep kind of way.
Yeah.
We're decreasing pretty quickly. I agree with you on that. But what's happening on the green graph?
It's increasing.
I want you guys to focus on the blue graph where it's increasing. Let's go with Carlos's idea. When the blue graph is increasing, when f is increasing, what is true about f prime? There is something that's true. That whole interval where f increases, what's true about the green graph? We already tried increasing, that didn't work. There is something that's true. F is increasing. F prime, your green graph, is the derivative. What do we know about the derivative if the function's increasing? I'm not telling. That's not how this works. If your function's increasing, what has to be true about the derivative? The derivative has to be
Positive.
positive. Look at the green graph. On this entire interval where we see f of x increasing, what's one statement that is absolutely true about the green graph? The green graph that entire time is positive. It is above the x-axis. So when f is increasing, f prime is positive. Maybe you want to put a little note above the x-axis. We're looking just on this interval where f is increasing. So that's like one of the things that's true. What else are we seeing? I'll take anything from anybody else. What do you see, Beto?
Oh, when the blue line reaches
Okay, careful. I agree with you that it's blue, but it's not a line.
it's the function
When the function, when f of x is what?
is like a little constant thing.
The little constant thing like there?
Horizontal
Yeah, there.
constant.
When it was horizontal, when f of x is, I'm going to write this as f has a horizontal tangent line. Please get that written down that way. When f has a horizontal tangent line, what's true about the derivative?
It's at 0.
The derivative is at 0. Let's see if we can actually get it. I want you to stop sliding when that tangent line gets horizontal, if you can, Abraham. So click the slide button again.
Ooh.
Oh, keep going.
Ooh.
Ooh. Well done, son. Well done. Tangent line's horizontal. What's happening on the green graph?
It's at 0.
It's 0. It has a root. So when f has a horizontal tangent line, f prime equals 0. So you could say has a root. So how many roots for the green graph?
2.
There's 2.
Yes.
There's one of them right over here, and then there's another one right over here. The tangent line would be perfectly horizontal over here. Now, there's 2 different vocabulary words that I want to focus on. Right here on this graph, I think you guys know what to call this.
Origin.
It is the origin, but on the graph, there's something special happening over here. This is a minimum. Specifically, I want to call it a relative minimum. Okay, this guy over here is a relative minimum. Way back in pre-calculus, you guys talked about absolute minimums and relative minimums, absolute maximums and relative maximums. Now this guy over here is not a minimum. It's not a maximum. It's a word that I don't think you guys have been introduced to yet. It's called a saddle point. Please add that onto your graph. It's a saddle point. Why would they call it a saddle point? Like a saddle that you would put on the horse, you put it on like the flat part? Or ish. Right, so I kind of look at this as like, it's kind of like a horse. The graph is increasing, flattens out, increases some more. This guy over here is a saddle point. So when f is increasing, f prime is positive. When f has a horizontal tangent line, f prime is equal to 0. How about this? When f is decreasing, what's happening? F is decreasing, the blue graph decreases, what has to be true?
Is increasing.
Is negative.
If f is decreasing, here's the place where f is decreasing, right? What's happening on the green graph? Right, it's down here, it's negative. F prime is negative, so below the x-axis. Okay, a couple of other thoughts here. When f has a relative minimum, what happens with f prime? At this minimum, the blue graph changed from decreasing to increasing. What happens on the green graph? F just changed from decreasing to increasing. What does f prime have to do? What is it doing on the graph?
Is it going down?
Not going down, because we're reading left to right.
Or going up?
You went from decreasing to increasing. Look at the green graph. What's happening on the green graph? You're going from below the x-axis to above the x-axis. So this means that f prime, I'm going to use triangle for change, changes from negative to positive. We don't have an example on this graph, but I hope this one makes sense. If f has a relative maximum, what has to be true? F has a relative maximum. Your function changes from increasing to decreasing. What about f prime? F prime has to change from positive to negative. Okay, quick review from yesterday. And we can thank, I think it was Jeanette asked about this. She wanted to know, is the graph of f differentiable? Turn to the person next to you. How would you figure that out? Is the graph of f differentiable? What is it that you have to check for? There's a couple of things you're going to look for if you get the graph. One of them I've already heard. The graph has to be continuous. If we're going to be differentiable, the graph has to be continuous. Is the graph of f continuous? Right, I can see the graph. This is easy. I can draw that blue graph without picking my pencil off the paper. Good. What else? What else? If the graph is differentiable, the function has to be continuous. So I see Carlos is doing this thing to the left and the right. The graph is continuous, but there's something else you look for with differentiability. Not the limits. The function has to be continuous. And there can be no
Jump.
not holes, not jumps. Nope. No vertical tangent lines. Right, differentiability, you first check for continuity, you look for a vertical tangent line, and there's something else you look for with differentiability. You look for cusp points, you look for a sharp point. Do we have any of those things happening?
No.
Absolutely none of those things are happening, so is the graph of f differentiable?
Yeah.
Even easier, is the graph smooth? Absolutely the graph is smooth. Smooth like Carlos and I are smooth. Everybody good? And Roberto is still smooth. All right, so let's put your money where your mouth is. On the bottom, page 13, there is another graph. Abraham, if you could go to the very bottom. Actually, let me give these guys the instructions first. Graph of page 13 at the bottom. I want you to sketch. Use a pencil only. What does that derivative look like? If you were to sketch it by hand without using the computer, what would you do?
No. I'm going to do them 20 down. it's either like that.
Yeah, that's what I was thinking.
That's what I thought.
What are all the things you know about this graph, and what does it mean about the derivative?
Are you doing it again?
I'm not seeing a perfect sketch yet. There are some reasons why this cannot be your graph.
It cannot.
Absolutely cannot be that graph. Things that we just talked about. If the graph of f is increasing, f prime is positive. If f has a relative max, f prime changes positive to negative.
What do you mean you don't know?
So,
Well, if you like, if you
All right, here comes the moment of truth. Abraham, slide X, please. Okay. Pay attention to f prime.
ooh.
Okay, show f prime, please. Next to the next one. That's the graph. Number one, fix your graph so that it matches this one. Number two, why does it look this way? What are the things you know
Isn't it like a
about
beta
the
function?
original graph?
Isn't that like a parent?
What are the things that you see about the blue, and how should it help you build the green? Nobody had the right graph for the green, and that's okay. But what are the things you see about the blue graph, and what it has to tell you about the green? I'll take anything from anybody.
I only.
What do you see about the blue graph, and what does it tell you about the green?
When it has like a
Jackie.
vertical, you know, when it has a vertical asymptote.
It has a vertical what?
I mean, sorry. On the blue, when it like
On the blue, when what happens?
when the tangent is like.
When the tangent line is, oh my God, there's just one word I'm hoping you're going to say next. When the tangent line is, begins with a V,
Vertical.
ends in vertical. When the tangent line is vertical, Abraham, see if you can use your magic skills and get it to stop when the tangent line is vertical. It's going to be way hard. Now we get audience participation. Okay, here's what you can do, Abraham. You can also slide. Wait, stop.
That's some hoe.
You can also grab the
Oh, the camera.
What? Make me some work.
Hi. Back to me. I think Jackie may have said something she didn't mean to. Okay. It's going to be way hard, if not impossible, for Abraham to actually get this. But Jackie's point was, there's a place where she sees a vertical tangent line. Where?
At x equals 0.
At x equals 0. Add this onto the graph, please. They're really hard to know for sure, but you have a vertical tangent line at x equals 0. What's true about the derivative there? How is the green graph behaving at a vertical tangent line? And this is like the next key point. When f has a vertical tangent line, what's true about f prime? Look at that green graph. What's that behavior? What's f prime doing? You're increasing towards what? Positive infinity. What's happening on the derivative? F prime has a vertical asymptote. Abraham, if you could just close that out. Okay, F has the vertical tangent line, F prime has the vertical asymptote. Now what I saw in a lot of graphs is a lot of people were saying, well, the blue graph is increasing. So what does F prime have to do? Blue graph is increasing, F prime has to be
Decreasing.
not decreasing. Go back to your notes.
Positive.
F is increasing, F prime is positive. Is this graph behaving the way it's supposed to be?
Yeah.
Absolutely. It's increasing. It's positive, sorry. F was increasing, F prime is positive. But because you're getting closer to this vertical tangent line, you increase faster, 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 faster. On this side of the graph, the blue graph, still increasing. F prime, still positive. What happens though is as you head out on the blue graph towards infinity, what's happening to those tangent lines? It's not that they're decreasing.
Constant.
They're not constant.
Isn't it an asymptote?
It's kind of like an asymptote. They're flattening out.
It's reaching a point.
What's happening, those tangent lines are flattening out. Your derivative graph gets closer and closer and closer to zero because we're looking at slope stuff. I'm going to say mission accomplished for today. This is what I wanted us to do, is start making these connections. Tomorrow we're going to be much more formal. Assignment number 24, rounds 1 and 2 are due tomorrow for a grade.